would like to welcome Olger on stage to talk about his experiences using Axon at MN Services. Olger, the stage is yours.
Well, thank you. That was a short introduction. It was actually trying to scare me with a small introduction on some of the adventures we had down in 2012. I think that was about the moment that we started to use Axon from our technology, and nowadays we use it at different places, and one of them is MN. MN is actually doing the execution for a pension fund, and they invest around $130 billion or euros, sorry, in order to ensure that 2 million people actually get some money when they retire. I'll need this thing, right? Sprong is the company where I work for. There are some of the people over here from Sprong, and together we help MN to actually move their current infrastructure towards something that you could say is microservices based. I grabbed one of the slides of the enterprise architecture board, and I'd like to explain you a bit about the landscape we are in, because it's a great drawing with in the lower corner everything that contains the data about employers and employees and their income. And when you go more to the outside, it's more or less dependent on everything that's inside. So when you're in the top left, it's about web applications used by employers and employees to look at their income data or change it. It slowly dribbles down to this red corner where everything is stored. And these things are all built somewhere starting in the 90s. So they're all built with a database. So there is an Oracle database behind, a huge one. And say one of these small things, the RLE thing over here, so I'll just walk around and show it. That one. That's this one. And that's only one. So the other ones look similar. And say the more you get outside, there are external services. So these are not data oriented. So if you want to change these things, it's quite a challenge. And the other thing that has happened, because this was built in the 90s and then you use stored procedures to actually get some business logic inside, that was normally how you did things at that time, and then you put a 4GL user interface on top of it, and then you start talking to the stored procedures. The stored procedures are the API. And that's how these things were built. But I'm not sure, I think somewhere in the 2000s, we ended up with service-oriented architecture. That was a way to newly extend your system. And it was another thing just to add a service bus on top of it with web services, and these web services started to use all these different stored procedures. So, well, you could say it's a monolith, you could say it's a big ball of mud. It depends a bit on what you do and how you actually separate these things. But we found that all the web services make use of all the different stored procedures, and all the different stored procedures make use of all the different schemas. And then you have duplication in functionality within the different schemas, because it's very hard to change stuff of other people if you're not sure what's going to happen when you change it. So it's a monolith. It has one big advantage. It can be deployed as one thing, and that's very easy, because deployment or automated deployments is quite another challenge that you need to fix if you want to do it with microservices. So But this advantage is actually the same disadvantage, because you have to deploy it as a whole, and it's actually built as a whole by around 12 different teams. You need to test it as a whole, because you never know that changes of someone else will actually end up in breaking stuff you have done. And next to that, say, oh, that's actually what I said, so I'll just continue. So, how are you going to change this thing? And we had, or actually by coincidence, we were lucky that we were asked to start on the top side. We were asked to start with a web application for employers. And you can do that in different ways. You could actually just attach it to this old school architecture. But we found that the time you need to actually process messages with this architecture takes around 15 to 30 seconds. So, well, I don't think that's the experience you'd like to have for your people that need to actually fill information in this system. So we decided otherwise. But still, you could actually build something on the side and then do some message queuing in between, and then you can continue. But we, with our experience with Axon and event-driven approach, we decided to do it different. So, with the fact that we had to start here, and we had to get the data from there is one other thing that is important, is that this data is changed in the meantime. So in order to make it a bit more complex, the data that is entered on the outside is not the data that's kept in the inside. Because one of the things that happens, and that's one of the things in the outside over there, it's called the local administration service. It's used in the Netherlands to check personal details by local governments. And actually, if they figure out that at the local government that you are actually living at another address than the address you gave to your employer, they'll fix it for you. So the employer knows where your actually living address is. But from a privacy perspective, that's illegal. So this thing is actually changing data underneath, and you can't show it anymore. Which means that if you take from a user experience, user perspective, people start to enter data into this system, it's changed, you cannot show it anymore, so you can't tell them what's in there. And that's something we really wanted to change. So that's where we started. So we built a new web application for communication with employers, that's where we started. And we did it in such a way that we wanted to limit the rework on the enormous application underneath, because when you start changing stuff over there, you never know what's going to happen. And I have to check my slides, sorry for that. The other thing what we wanted to try, I can look over there, is that the data that's entered within this separate system, it's actually clean data. You can show it to the people using it, because it's not changed underneath, it's under your own control. And with this clean data, it gives us an approach to actually start to adapt to other sites. You could start a microservice architecture by adding event-driven applications to this data, because the moment you have the data of the employers, you more or less have all the data you need to decide how a pension is built up, what people need to pay, what do you need to pay to them, when you need to start. So it's basically a real starting point to renew everything else. But in the meantime, everything just needs to keep running, so we decided to make it in such a way that we had a separate Axon application, and next to it we had this other monolith. We used some diagramming to show what we did, and actually, as you see, it's quite simple. It's nothing special. It's a web application with a separate front end and API, and we use Swagger for that, not Swagger app, but normal Swagger stuff. And this application more or less stores all the data the employers give us. And then it starts to talk to this other system. And this other system is available via these web services. It's Oracle Web Services. And on the other hand, say that the other thing that we did is that the employers that actually make use of the system could also call. So the other thing that can happen is that next to this system, changes are actually pushed into this old monolith, and then we need to know from the other side. And say one of the big issues we had and had to solve is actually integration. Because when people start calling a service desk to tell that their employee left or they have a new employee and that their salary specs are like earning a couple of €1,000 a month and for next month it will change, and then people start to type this via Oracle forms into this monolith, then all the data is in there. But you never know that it actually happened from the side of our web application. So we need to find a way to actually get this organized, especially when you talk about new people, new employees. So how do you recognize it's new or old? And that's quite a challenge. So the real thing I'd like to talk about from a domain-driven design perspective is the anti-corruption layer. So we more or less decided to make this simple web application and spend quite some effort to create a separate part that would listen to all the events and decide what to do with them. And when something came back, we used a GMS queue for that. We had to figure out how we could actually reintegrate it into this, into our system. And in order to do that, we found that Axon Saga pattern actually works quite well. It keeps long-running transactions, and one of these transactions actually takes days. If something is wrong in the data given, in effect, people actually by hand are going to look at it, and within 5 days they may react. So you'll never be in a IT-based transaction scope of maybe a second. As we started this quest to get a separate application next to the old application, say there are a lot of risk management around, especially in financial institutions. So we try to find a way to make it as easy as possible and ensure that we couldn't mess up. And most of the times when you move things out, you need to migrate. So you have your complete system, and then you take a piece, this piece is separate, then you move data from your old system to your new thing, then you have a new system and the old system next to each other. When something is wrong with this new system, you more or less have a challenge, because you need to actually fix the data within the new system. And because we had this old monolith that needs to keep on working, we more or less have all the data there. So what we could do is, when something goes wrong, we could actually remove all events, remove everything in the query stores, and just ask the system again to do a migration for a very small part of the data. So we could do a migration for one employer with a number of employees. And when something is wrong within this system, you could just do it again. And from a risk perspective, it basically means that nobody needs to worry that it's completely correct up front. Because guarantee of things being completely correct up front, well, in my time in building software, there's always something that went wrong, and then you need to fix it. And with this style of working, at least it doesn't take too much time. Always like the Axon reference guide picture, just to give you a bit of an idea. So the application is quite simple. It's got two aggregates. It's an employer and employee. They have a connection based on an ID. And when data is added or removed, it's more or less mimicking a REST style approach, data added, data removed, but specific. So specific for the kind of data, salary changed, those kind of events are in there. And we use those events to listen via the event handler and Saga and push it to the ESB. And in that way we can keep track of if everything goes well. And when things actually go wrong, we have a separate structure where people can by hand fix stuff and then re-push it into this integration layer. And so it's now operational for a couple of months and it's doing reasonably well. When we started at MN, we had one other goal. Because of the way the software is structured with a large Oracle-based database, we found that deployment takes time. And we really wanted to show that if you start to deploy more frequent, actually deploy continuously, you could actually improve on your quality. And next to that, you could improve your quality. You have more features to the people that need to use it sooner. So what we try to do is that we show with this component that you can deploy continuously without breaking things. And basically the whole trick around it is if you reason of what to do is everything that shortens lead time, so the time you take to get from an idea that you want to build towards this idea being in production. The more you shorten the lead time, the more features you can push, the more you can do frequently, the better your quality will be in the end. And in order to do so, we actually started to edit a CI/CD structure that went one step beyond the normal CD. So it's next to the unit tests and the coverage percentage. That's, I think, most of the people that do continuous integration delivery, they'll probably use that. And you can break on coverage percentage, for instance. We found a way to actually do the architecture diagram, the C4 architecture. It's actually based on the things Simon Brown talks frequently about. It's a very simple language and it's got its own structure. In describing architecture, you can start comparing these things. So you can see if things have changed. And this diagram, and we have a bit more complex diagram behind it, are generated based on the code inside. So by generating this diagram, each time we build it, we can check if nothing really happened that affects the architecture in the wrong way. One of the other things that you could do is protect your package structure and those kind of things. So if you have one deployable unit, and our web applications, actually it's two units. One is the JavaScript front end, and it's got a Spring Boot backend. And within this backend, you have different packages and the integration layer. And you want to prevent that this integration layer actually becomes part of your core logic. But they're deployed together at this moment. And if you want to prevent that from happening, there are some tools available that could actually just check your package structure, see if you're not using things from the wrong end and fail your build on it. So you can do some architectural build checks with that. And that's still all what you can do in build phase. We found that compliance at MN is really important, truly, rightly so. And you have a lot of things that actually happen after you are ready with building your software. Most of it is about security. And so if you want to shorten the time in that area, you probably need to find another way to get this security inside your process. So most of the times you have your application finished and then you go to the security department and you'll call them and they say, yeah, and 2 weeks from now we have some room and we have penetration tests ready and set up, and we can penetrate your application to see if it's fine. And so in 2 weeks from now you can deploy. What are you going to do in the meantime? How are you going to keep everything you're working on in the meantime in sync with what's going to be deployed in 2 weeks from now? And why do you need to wait for 2 weeks? You could do these things automated. Say with the OWASP containers, they're freely in Docker available. You can wire them in such a way that you can just automate the complete testing before the deployment of your application. And the same counts for load testing or integration testing and that kind of things. So that's the other thing we try to do. It's certainly not finished. It's quite a job to get it all organized, but makes it together with the Axon approach a real interesting project. And that's all I wanted to tell you. So if there are any questions.